Welcome F5S students. Today we are going to discuss about Heaviside unit step function and Dirac Delta function. Dear student, yesterday we can complete this example of previous lecture. Now Laplace of f of t minus 4 u of t minus 4 is equal to e raised to minus 4s es is equal to e raised to minus 4s fs is 16 upon e square plus 8 upon e square plus 2 upon es cube. Dirac delta function. Laplace transform of Dirac delta function. Definition: Dirac delta function or unit impulse function. Another name of Dirac delta function is unit impulse function. Consider the function phi the function phi defined as phi of t minus a is equal to 0 if t is less than a, 1 by epsilon if a is less than or equal to t less than or equal to a plus epsilon, 0 if t is greater than a plus epsilon. Then limit epsilon tends to 0 phi of t minus a is known as Dirac delta function. Dirac delta function and is denoted by delta t minus a. Thus, delta t minus a is equal to limit epsilon tends to 0 phi of t minus a. The graph of phi of t minus a is as follows. Phi of t minus a t 0 a plus epsilon from 0 to a function phi of t minus a is 0 from a to a plus epsilon the constant function 1 upon epsilon. Again from a plus epsilon to infinitely, it is 0 function. The area under the graph is unity. In particular, if a is 0, then delta t is equal to limit epsilon tends to 0 phi of t, where phi t is equal to 0 if t is less than a, 1 upon epsilon a less than t less than or equal to a plus epsilon, 0 if t is greater than a plus epsilon. Here a only. If t is less than 0, because a is 0 is here, therefore 0 less than or equal to epsilon, 0 less than or equal to t less than or equal to epsilon, t is greater than epsilon. Laplace transform of prove that Laplace of delta t minus a is equal to e raised to minus as, where delta t minus a is a Dirac Delta function. Dirac Delta function. So, first we find Laplace of phi of t minus a, then we take limit as epsilon tends to 0. But definition of Laplace transformation. Laplace transform. Laplace of phi of t minus a is equal to 0 to infinity e raised to minus ct phi of t minus a dt. By definition of Dirac Delta function, we divide this interval into three parts: 0 to a to a plus epsilon, and 0 to a e raised to minus st. The value of the function is 0 dt plus a to a plus epsilon e raised to minus st. Function phi t minus a in this interval is 1 upon epsilon dt plus a plus epsilon to infinity e raised to minus st 0 dt. The value of phi of t minus a in this interval is 0 is equal to, this becomes 0 plus 1 upon epsilon. 1 upon epsilon is constant with respect to t. A to a plus epsilon e raised to minus est dt plus 0 is equal to 1 upon epsilon. Integration of e raised to minus st with respect to t is e raised to minus est upon minus s from a to a plus epsilon is equal to 1 upon epsilon for upper limit e raised to minus s a plus epsilon upon minus s minus for lower limit e raised to minus sa upon minus s is equal to 1 upon epsilon. This minus minus becomes plus e raised to minus as upon s minus e raised to minus as into a raised to e raised to minus s epsilon upon es is equal to, here e raised to minus as upon s is common to both. E raised to minus as upon s 1 minus e raised to minus s epsilon upon epsilon. We put this 1 upon epsilon in the bracket. It is Laplace of phi of t minus a. Now to find Dirac delta function. Now delta t minus a is equal to limit t tends to epsilon e raised to minus as upon s 1 minus e raised to minus s epsilon upon epsilon is equal to, with respect to the limit, e raised to minus as upon s is constant. Therefore we write e raised to minus s upon s limit t tends to epsilon 1 minus e raised to minus s epsilon upon epsilon is equal to, using L'Hospital rule, using L'Hospital's rule, e raised to minus as upon s t limit t tends to epsilon, where the value derivative of 1 with respect to epsilon is 0 minus derivative of this with respect to epsilon is e raised to minus s epsilon, again derivative of s epsilon is minus s, therefore here plus s upon 1 is equal to, therefore take a limit is equal to e raised to minus as upon s, take a limit t tends to epsilon, we get e raised to 0 is 1, therefore es. S's get cancelled, we get e raised to minus as. Laplace transform to that theorem. Laplace of ft delta t minus a is equal to f of a e raised to minus as, where delta t minus a is a Dirac Delta function. Proof. First, we find Laplace of ft phi of t minus a. Then we take a limit as epsilon tends to 0. By definition of Laplace transform, Laplace of ft phi of t minus a is equal to 0 to infinity ft e raised to minus st ft phi of t minus a dt. We divide this interval 0 to infinity into 3 parts. 0 to a e raised to minus st ft using definition of Dirac Delta function, phi of t minus a for this interval 0 to a is 0 dt plus a to a plus epsilon e raised to minus st ft phi of t minus 1 upon epsilon dt. The value of the function phi of t minus a in the interval a to a plus epsilon is 1 by epsilon as per the definition of Dirac Delta function. A plus epsilon to infinity e raised to minus st ft, again the function of phi t minus a is 0 in the interval a plus epsilon to infinity dt is equal to 0 plus 1 upon epsilon a to a plus epsilon e raised to minus st eft dt plus 0 is equal to 1 upon epsilon a to a plus epsilon e raised to minus st ft dt is equal to 1 upon epsilon into epsilon. For this integration, we know that standard formula e raised to minus yes a plus theta epsilon f of a plus theta epsilon. How? Since by Lagrange's mean value theorem of integrals a to a plus ch fx dx is equal to h f of a plus theta h, where theta goes from 0 to 1. Theta belongs to open interval 0 to 1. Is equal to epsilon epsilon get cancelled. E raised to minus yes a plus theta epsilon, here epsilon f of a plus theta epsilon. Now Laplace of ft delta t minus a limit t tends to epsilon, epsilon tends to 0, ft ft phi of t minus a is equal to limit epsilon tends to 0 e raised to minus yes a plus theta epsilon f of a plus theta epsilon is equal to e raised to minus as into fa. Find example. Laplace of sin 2t delta t minus 2. Solution. Take ft is equal to sin 2t. Now Laplace of ft phi of delta t minus a is equal to e raised to minus as into efs. efa. Laplace delta t minus 2. Therefore, Laplace of ft delta t minus 2 is equal to e raised to minus 2s f of 2. Therefore, Laplace of ft means sin 2t delta t minus 2 is equal to e raised to minus 2s f2 is sin 4. Next example. Evaluate zero to infinity e raised to minus 4t delta t minus 2 dt. Solution. We have Laplace of delta t minus 2 is equal to e raised to minus 2s is equal to, therefore, by definition of Laplace transform 0 to infinity e raised to minus est delta t minus 2 dt is equal to e raised to minus 2s. Put s is equal to 4, 0 to infinity e raised to minus 4t delta t minus 2 dt is equal to e raised to minus 8. The value of s is 4. 2 into 4 is 8. E raised to minus 8. Okay, we stop here.